Welcome back for another deep dive. Today we're looking at some really cool research from Alibaba. It's about making large language models more reliable,
Ah,
especially
yeah,
as we're starting to use them for, more and more complex things like advanced reasoning.
right.
The paper is called ProgCo. Program helps self-correction of large language models. And
Okay.
the reason it caught my eye is that it uses code
Interesting.
to help the LLMs double-check their work.
Huh.
So,
Um, so the thing is, right now we have these LLMs
right.
that are really good at generating text,
Yeah.
but they're not so good at catching their own mistakes.
Uh-huh.
The Alibaba's team wanted to see if they could give these LLMs a better way to understand their own output so they can verify it and then refine it,
Okay.
you know?
Yeah, that makes sense. So they came up with this
They call it ProgCo.
ProgCo.
It's a two-step system for self-correction.
Okay.
Yeah.
So the first step, that I guess, is ProgVe.
Yeah, ProgVe is a program-driven verification.
Program-driven verification.
And that's all about creating a set of rules,
Okay.
almost like a blueprint
Got it.
for the LLM to follow.
Like a checklist.
Yeah, it's like for each task, the LLM can create a specific customized checklist.
Huh.
So for example, let's say you ask the LLM
Yeah.
to write a letter to a friend about voting,
Mm-hmm.
and you tell it to write the whole letter in lowercase.
Okay.
ProgVe would then make a program that specifically checks for those things.
So it's really,
Is it formatted like a letter?
Yeah.
Is it in lowercase?
it's really going through with a fine-tooth comb.
Yeah, it's very detailed.
And then if it finds a problem,
That's where ProgRe comes in.
it's ProgRe.
Program-driven refinement.
Okay.
And that uses kind of a two-part refinement process.
Interesting.
Where the LLM first tries to fix any errors
Right.
based on what the program told it.
Mm-hmm.
And then it compares the original
Yeah.
and the revised responses.
Oh, that's a good idea.
And from that comparison, it can figure out, how to refine it even further.
Kind of like an editor.
Yeah, like a human looking at different drafts.
Wow. So it's not only refining the responses,
Right.
it's also refining the program itself.
Exactly. It learns as it goes, and it gets better with each round.
That's so cool. So the researchers wanted to know if this actually worked.
Of course.
So they tested it
Yeah.
on a bunch of different benchmarks.
They used IFEVL for instruction following,
Okay.
and then GSM-8K and math.
Uh-huh.
Both of those are about mathematical reasoning,
I see.
which can be really hard for LLMs.
Yep.
And the results they got were really quite impressive.
Okay.
So ProgCo consistently did better than the other self-correction methods
Really?
on all three of the benchmarks.
That's amazing.
For GSM-8K, for example.
Mm.
After 3 rounds of correction,
Okay.
the accuracy of GPT 3.5 went from 76.5% to 83.78%.
Wow, that's a big jump.
And on math, which is super tough,
Yeah.
it was even better. It went from 36.2% to 44.2%.
That's huge.
But what's even more interesting is that ProgCo was much better at recognizing when the responses were wrong
Really?
compared to the other methods.
Huh. So it seems counterintuitive
Yeah,
that using code would be the key to better self-correction in language.
I know. It's interesting, right?
Yeah. But I guess it makes sense when you think about it.
Well, code is very precise.
Uh-huh.
It's not ambiguous like natural language.
Right.
So you have to be very clear,
Yeah.
precise when you're writing code.
So it makes the rules
Right.
for checking the LLM's output
Yeah, it really defines the rules.
very clearly.
Mm-hmm.
And that leads to much more effective verification and refinement.
Right.
And the fact that you're using code opens up
Yeah.
all sorts of possibilities because
Yeah.
the researchers found
Mm-hmm.
that they could actually add external tools
Oh, wow.
like calculators
Yeah.
and symbolic solvers
Wow.
to boost ProgCo's performance even more.
That's cool.
So, for example, when they used a Python tool
Mm-hmm.
for really complex calculations, it actually improved the performance
Oh, wow.
even more on IFEVL and math.
Really?
Yeah.
That's great. It really makes you think differently about LLMs,
Yeah.
They're not just language models. It
Yes.
seems like they're capable of
Yeah.
a much deeper level of understanding
Uh-huh.
and reasoning.
So how does this compare to other ways of getting LLMs to self-correct? Like,
Yeah.
what about self-consistency sampling?
Oh, yeah, where it generates a bunch of responses and then
Yeah.
picks the best one.
Right, exactly.
Well, self-consistency sampling can be a real resource hog
Uh-huh.
because it has to generate all those responses.
Yeah.
But what they found with ProgCo
Yeah.
is that even after just one round of correction,
Okay.
it often beats self-consistency sampling with multiple samples.
Interesting.
Yeah.
So the paper also talks about
Mm.
this idea of reverse reasoning. Which sounds kind of strange.
Yeah, it does.
It's like checking the answer key
Right.
before you even solve the problem.
Yeah, instead of looking at every step the LLM takes
Yeah.
to get to a solution,
Right.
ProgCo just checks the final answer.
I see.
It works backward using the information that was given
Mm-hmm.
to see if the answer makes sense,
Oh, okay.
if it logically leads back to the beginning.
So it's a more efficient way
It is,
to verify things.
especially for really complicated problems.
Yeah, that makes sense. And then they also talk about how this reverse reasoning can be used to refine the program itself.
Yeah, you can see it in figure 14 of the paper.
Okay.
They show how ProgRe uses reverse reasoning not just to find errors in the program, but also to suggest how to make it better.
So it's like a feedback loop.
It's constantly making the verification process stronger.
That's pretty cool. Now, they didn't just look at one LLM, did they?
No, they tried a bunch of different ones,
Oh,
like
yeah.
GPT 3.5, GPT 4.0, and Llama 3.18b Instruct.
Wow, so a good variety.
And ProgCo made them all better.
Okay.
But the amount of improvement was different for each model.
Interesting.
So it really highlights how important it is to pick the right LLM for the job,
Uh-huh.
depending on what you're trying to do and how well you need it to perform.
So they also looked at what happens when you let the LLMs do multiple rounds of self-correction, right?
Yeah, they went up to 5 rounds.
Okay.
And generally, the performance kind of leveled off after a while.
I see.
So it seems like there's a sweet spot,
Yeah.
where you have to balance
Right.
the performance with how much computing power you're using.
That makes sense. Now, the research didn't just focus on how well ProgCo performed overall, right?
Right. They also wanted to see how well program-driven verification stacked up against other methods, like checklists and co-t-check,
Yeah.
and ProgVe consistently came out on top.
So what do they think is the reason for that?
Well, they think it's because code is so clear and precise. There's no room for ambiguity like you get with natural language.
Yeah.
So you can do much more complex verification procedures.
This research really lays the foundation for some exciting possibilities with LLMs in the future.
Definitely. The fact that they can self-correct, this opens up all sorts of new avenues for using them. It's not just about generating text anymore.
Right.
We're talking about LLMs that can solve complex problems on their own.
Yeah. That's amazing.
And this research really gives us a glimpse into what that future might look like.
It does, and it's pretty incredible. This Alibaba research, it doesn't just show that ProgCo works,
Right.
They also dug into some of the details
Mm-hmm.
of how this system works.
Yeah.
And there are some really interesting insights there.
Like what?
Well, one thing they found is that ProgCo isn't limited to just one type of task.
Oh, really?
Yeah. They saw impressive results on both instruction following
Mm-hmm.
and mathematical reasoning,
Uh.
which are pretty different challenges for LLMs.
That's interesting.
So it seems like this program-driven approach to self-correction,
Yeah.
it could be useful for all sorts of things.
Right. It's not just for specific problems.
And the research also took a closer look at self-verification.
Yeah.
They compared ProgCo's program-driven approach
Mm-hmm.
to other methods like checklists,
Okay.
and ProgVe consistently did better.
Why do they think that is?
Well, they think it's because code is so unambiguous.
Right.
It's very clear and precise.
Yeah, that makes sense.
So the rules for verification are well-defined,
Right.
and that leads to much more effective error detection.
So it's like the code is making sure everyone is on the same page.
Exactly. And remember we talked about how you can integrate external tools?
Yeah.
That adds another level of sophistication to the verification process.
It does.
This research from Alibaba has really given us a lot to think about.
It has.
It's clear that ProgCo is a big step forward in tackling the problem of self-correction in LLMs.
Absolutely. Using a program-driven approach like this
Yeah.
could make LLMs much more reliable. And that opens up so many possibilities for how we can use them.
It does. It's really fascinating to see these kinds of developments pushing the boundaries of what LLMs can do.
I agree. It's an exciting time to be working in this field.
It really is. Well, thanks for joining us for this deep dive into the world of LLMs and self-correction. This research from Alibaba is truly groundbreaking, and it'll be fascinating to see where it leads in the future.